1 million kilograms of volatile explosives, bolted to a $1.5 billion spacecraft containing 7 precious national heroes. If these rockets go off the way they should, they will propel the space shuttle into orbit. And only if it goes perfectly. These people will fish them out of the ocean and use them again and again and again. But if they get even one thing wrong, one misplaced bolt, one blown seal, then it's just a bomb that will kill everyone aboard. It's happened before. Cape Canaveral, Florida. Space Shuttle Endeavour starts crawling slowly toward the launch pad for its 23rd mission into space. Lashed to its belly, the 2 solid rocket boosters that will propel the shuttle out of the Earth's atmosphere. In all, it's a 2 million kilogram package riding on a massive tracked sled. Its top speed as it heads for the launch pad, 1.5 kilometers per hour. It'll take 5 hours to get to the pad. The solid rocket boosters are 45 meters high, 4 meters wide, the biggest in the world, and the most powerful. They have to be. That's because the solid rocket boosters, or SRBs, have to produce enough brute force to lift the 2 million kilogram space shuttle off the ground safely. At launch, the SRB's fuel is lit, and at 67,000 meters altitude, they will be spent. The empty tanks will be jettisoned off the shuttle, falling harmlessly into the ocean off Florida. At least, that's the hope.
PLT, perform APU pre-start.
It's launch day. In 7 hours, Endeavour is scheduled to lift off the 127th space shuttle mission in the past 30 years. It will be carried by 2 solid rocket boosters. The real tricky part is, these are not new SRBs. They've launched space shuttles before, multiple times before. It's like a used car. If you're riding in it, you can only hope it's been taken care of. In 7 hours, the world will find out. 250 kilometers away, the crew of the ship Freedom Star prepares for their mission. They will fish the spent SRBs out of the ocean after liftoff. At the helm of the Freedom Star is Captain Kirk. Really, George Kirk is the man in charge of this part of the space mission.
What do you have?
New contact, Cap.
About 13 miles off the port bow. See anything, Anthony?
It's like the overseas Boston.
It's 3 hours until launch. 3 hours and 6 minutes until the solid rocket boosters hit the water. And right now, it's Captain Kirk's job to keep the waters in the landing area clear of other ships. It takes precise calculation of wind speeds and water conditions for the crew to figure just where the SRBs might splash down.
Kirk, this is what we got here. Can you plot him on there?
28 degrees, 20 north, 077.
That 176 square kilometer area of ocean is called the box.
Okay, that puts him in the southeast corner of the box, well in.
Okay, do you have a course and speed on him, Brent, from the radar or AIS?
But today, there's a problem. Another ship has wandered into the box.
Anytime during any sort of job, you can have something go south or go wrong, and then you have to make adjustments, and you have to make sure that you do it quick enough. So you always have to be on your feet.
Captain Kirk reacts quickly.
Overseas Boston, this is the motor vessel Freedom Star, requesting that you alter your course to 080 till 1500, over.
They're telling the Overseas Boston to move out of the box until 1500 hours, or 3 o'clock in the afternoon, long after his ship retrieves the SRB. The box is now clear, and Captain Kirk and his team are ready to spring into action. 7 minutes to launch. But even at the last minute, if there is just the smallest problem with the SRBs, Mission Control will cancel.
Mike, the engineering team is ready to go.
Okay, thank you, Charlie.
For now, the reused parts that make up the SRBs appear ready to go. The solid rocket boosters may sound complex, but they're still essentially a bomb with a brain and parachutes. At the top, a cone called the frustum that holds the parachutes that land the rocket gently into the ocean. Below that, the forward skirt that holds the self-destruct system that will blow itself up, if necessary, to prevent disaster. At the bottom, the aft skirt that serves as the booster's steering wheel. And in the middle, 4 segments holding 1 million kilograms of very flammable fuel. It's less than a minute to liftoff. Mission Control initiates the final launch sequence.
Sound suppression water system has been activated, protecting Endeavour and the launch pad from acoustical energy. We're go for main engine start. We have main engine start. 4, 3, 2, 1. Booster ignition and liftoff of Endeavour.
The SRBs ignite at T-0 seconds. At this point, there is no turning back. Their internal temperature quickly rises to 3,300 degrees Celsius, hot enough to boil steel. Now the real countdown begins. For 2 minutes, the SRBs burn and push the shuttle to 4,800 kilometers per hour. For the next 2 minutes before they burn out and separate, the shuttle is chained to this erupting bomb. If disaster happens, it probably happens here.
Endeavour, go at throttle up.
Right now, the launch looks as if it's going as planned. So was the launch in January of 1986. But 73 seconds after liftoff, the Space Shuttle Challenger suddenly exploded. All 7 astronauts were killed. 2003, Space Shuttle Columbia lifts off, and everything looks fine. 16 days later, the shuttle breaks up and burns apart during re-entry, killing all 7 astronauts aboard. No one knew it at the time, but the tragedy was set in motion during that normal-looking liftoff. That is the history facing Endeavour as it approaches the 2-minute mark.
1 minute 33 seconds into the flight. All systems continue to function well. We'll be standing by for burnout and separation of the solid rocket boosters.
120 seconds into the flight, at 47,000 meters altitude, the SRBs separate and the shuttle goes on under its own power. If you're a rocket scientist, this is where you hold your breath. Next stop for the shuttle, orbit. For the SRBs, it's re-entry into the Earth's atmosphere. A 400 kilometer per hour galactic skydive. They free fall for 153 seconds. Hitting the ocean at that speed would be like hitting concrete. So when the parachutes deploy, the tumbling rockets are slowed to 80 kilometers per hour. Captain Kirk and the crew of the Freedom Star must spot them. For them, this moment is as exciting as the launch.
I've hardly ever seen a shuttle launch because I'm always so far out at sea, but I get to see them like you do on TV. But the re-entry of the boosters is also exciting, and that's something that, you know, very few people get to see.
Oh, big splash today, boys! All right!
It's always a wild landing. The SRBs plunge into the ocean at highway speeds. They've landed 15 kilometers from the ship. It's go time for dive manager Larry Collins and his team to get the first one. The SRB is sitting up in the water like an iceberg. 10 meters pokes above the water, and at first glance, it looks okay.
You're in such a dynamic environment out in the middle of the ocean with splashdown and parachutes getting tangled, and it's a little bit different every mission.
But they won't know for sure until they look at the 33 meters that are under the water. The first step, unhook the parachutes. They'll be reused too. The topside crew spools them onto large reels. The next step sounds easier than it is. The horizontal flip, which will turn the rocket hulk onto its side. That will make it easier to carry to shore. The dive team sticks a gigantic plug in one end of the SRB and uses a 600-meter hose to pump out the water and pump in millions of liters of air. For Captain Kirk and the dive team, it's mission accomplished. For the solid rocket booster, its journey back into space is just beginning. And the next challenge for the crew? Get it out of the water. The Kennedy Space Center is waterfront property, complete with its own harbor. That's where the SRB, all 87 tons of it, will be lifted out of the water. That's where the straddle crane comes in. The straddle crane tucks a sling under the belly of the booster and slowly cranks it out of the water. Crews then lower the booster onto a customized dolly. It's then driven 68 meters up the tarmac, where it catches up with the other booster and the post-flight assessment team. As many as 100 experts, engineers, and technicians can't wait to get their hands on the spent boosters and find out how they did. The dolly can rotate the SRB, so the team can examine the booster 360 degrees. This first look is crucial to the safety of the crew on the space shuttle in orbit right now. That's because damage to the SRB could mean damage to the shuttle.
Our primary objective is to see if anything actually hit the orbiter. We assess all the hardware to see if it is damaged in any way, the metals, the electricals, and we just make sure everything functioned as is.
Anything out of the ordinary, even a tiny smudge or off-color liquid, must be noted by the team. No detail is too small, and today there's a mystery. It's an odd substance stuck on part of the SRB.
They found some yellow objects in one of the pieces of hardware. It actually was a drain where water was supposed to drain out. It was yellow.
No one knows what it is. It must be investigated. A lot depends on this inspection. If they don't catch a problem here, the safety of the crew in space could be in jeopardy, as well as the crew of the next mission. It's a lesson that was hard learned. In 2003, Columbia mission STS-107 liftoff looked perfectly normal. But 16 days later, the shuttle disintegrated on re-entry, killing all 7 of its astronauts. Experts were baffled. NASA's then administrator, Sean O'Keefe.
This is indeed a tragic day for the NASA family, for the families of the astronauts who flew on STS-107, and likewise tragic for the nation.
Searchers combed every inch of ground where the debris might have fallen. They found pieces, some of them tiny. But the shuttle was obliterated. The only intact part of the shuttle system, the solid rocket boosters. And they would hold the key to the mystery.
When we lost Columbia, we had the hardware here. We were locked down and we did investigations on everything that was left. See if we could figure out exactly what happened.
It took 7 months to discover that. And it turned out to be something very simple. A briefcase-sized chunk of insulating foam broke away during liftoff, piercing the shuttle's left wing. For 15 days, the mission carried on in space. But upon re-entry, hot atmospheric gases flowed into the small hole, weakened its wing, and destroyed the Columbia. That's why every detail, however small, must be caught right now when the SRB first comes out of the water.
The 1051 here, about 1.5 inches diameter.
If we start to have failure issues, we have before gone over to the launch pad and said, hey, this wasn't quite right on this flight, let's check it out for the next flight. So post-flight is very important for the flight you're on and future flights.
The assessment team has finished their inspection, and they have a verdict on the mysterious yellow stain.
They found out it was bee pollen from a tree over by the launch pad, so they can figure out what everything is. It's pretty neat.
The bee pollen is not a problem, and it won't interfere with what comes next, taking the rockets apart. This is the disassembly team. It's the job of these 25 people to dismantle the solid rocket boosters for more inspections and repairs. To take apart the largest sections requires a huge device called a horizontal separation fixture. And the smallest parts, like these cable connections, are pulled apart with simple hand tools. Some segments of the exterior are covered with insulated foam, toasted to a crisp by the heat of ascent. It takes 15,000 pounds per square inch of water pressure to knock it off. Each SRB has about 800 reusable parts.
Look at how big the boosters are. I mean, 12 foot in diameter. We take them, we process them down all the way to the bottom.
The solid rocket boosters are now becoming an unrecognizable pile of parts. Each and every one will be restored to good as new condition. It must be to avoid disaster.
The last one that went, it was important. The next one is even more important. You know, you don't want any errors, you don't want any problems, and that's what you work for.
6 weeks after launch, the 2 massive boosters have been dismantled into about 800 pieces. And each of those pieces must be individually treated before the next flight. This is a paint room, and this technician is spraying an epoxy paint to some of the smallest pieces. He will do this hundreds of times. His colleague inspects his work visually and touches up the smallest nooks and crannies. Double check, triple check. Redundancy is good. Same goes for the parachutes. If they're to slow the free-falling boosters to a survivable speed, they need to work perfectly. It's Terry McGugan's responsibility to make that happen.
We know that there's uncertainties that can happen. It's not a perfect world, and something can go awry, and when it does happen, we're ready to respond to it.
And the parachute's function is not as simple as it sounds. About halfway into the SRB's 5-minute free fall from space, a small pilot chute bursts from the nose cap and deploys a larger drogue chute. The drogue snaps the booster vertical, releasing the 3 main parachutes. The canopies decrease the booster's speed from 400 to 80 kilometers per hour, saving them from destruction when they smash into the ocean. The parachutes take a beating, and they're a mess of wet fabric when they come back from the recovery ships. The team washes off all the algae and seawater, then stretches out the canopies to prepare them for an intense visual examination. They're looking for any damage. If NASA hopes to reuse these parachutes, not one stitch of the nylon canopy can be ignored. The lead technician scrutinizes and tags the tiniest problems. By the time he's done, there will be hundreds of them. Each will be a repair. This technician is repairing a broken stitch using a simple sewing machine. Meet the repacking team. Once the chutes are repaired, it's their job to stuff them back into a frustum canister. A lot of it is old-fashioned physical labor and some fancy footwork. They also get help from hydraulic presses. It takes 12 days to repack the chutes. And there can't be any mistakes, or else it's unpack and start over. 4 weeks into the rebuilding process, the teams have separated and removed the 4 sections of the rocket that hold the fuel. But they're empty. Now it's time to ship them out to be refurbished and refilled. The crews carefully load each section onto rail cars. Destination 3,200 kilometers away. Brigham City, Utah, home to the next critical phase of the solid rocket booster rebuild. It's ATK Systems, a world leader in aerospace and defense. Here, 500,000 kilograms of solid rocket fuel will be packed into the boosters.
Ready, Danny? Okay, go ahead and break it over.
The team at ATK must take each rocket section, weighing in at 7,900 kilograms, and carefully move it into a pit to be refilled.
Real good.
These segments are called motors, and these ones have been refueled more than a dozen times.
Ready, down, slow. Down. Okay, go ahead and put it in micro.
The motors are given a 100,000 point inspection throughout the refueling process.
Get on the west.
Just getting them into position takes this crew up to a day.
Ready.
The technicians handle these massive metal hulks with care. They are the bombs the astronauts will be sitting on at liftoff.
Obviously, the hardware what catches your attention, initially. It's pretty impressive stuff. But I think after you see the hardware, that starts to wear off a little bit, and you really start to see it's the people. It's the people that make the real critical difference. Occasionally, we'll have astronauts. They provide feedback to the technicians, operators, and so it's really a very symbiotic relationship.
Ready on micro. Ready on micro. On micro.
The cap is removed, and the segment is in position. Now comes the big moment, refilling it with solid rocket fuel. The ingredients: aluminum, iron oxide, and ammonium perchlorate. Stirred in 600-gallon drums, the mixture starts out as a thick paste, like peanut butter. Then they are poured into the belly of the motor. Together, the fuel elements are stabilized and not at risk of exploding.
Okay, Tony, let's get this thing going. Go ahead and drop your dry materials.
Back at Kennedy Space Center, the tip of the rocket, the frustum, has been fully restored. And the protective foam they power washed off after the last launch needs to be reapplied. It's a skin that must be able to withstand temperatures of more than 3,000 degrees Celsius, 2/3 the temperature of the sun. A robotic arm sprays on the coating. It's such a precise job that technicians monitor the spray by the second. It's a mix of 3 different materials, including glass, epoxy, and ground cork. The application must be at least 2.5 centimeters thick, or the astronauts could burn up during flight. The teams are also readying the aft skirt. It houses the Space Shuttle's thrust vector control system. Think of it as the Space Shuttle's steering wheel.
we're going to torque that in the back. That's going to be 275 plus or minus 5.
The steering system keeps the thrust pointed in the right direction during liftoff. After clearing the tower, it rolls the shuttle on its back to get it on the right trajectory.
Here, Dennis, I'm going to have you verify the torque, 1,800 inch-pounds. All right.
Recycling this important piece is a two-technician job.
Okay. Good to go. Here's my backup wrench.
A stripped bolt here could mean disaster.
That's good.
If this system fails, the launch will be like letting the air out of a balloon. The shuttle could spiral in any direction. And that steering system, in turn, has a brain that had better be working during liftoff. It's called the Integrated Electronics Assembly, or IEA. It controls the SRB's most critical functions. It's the brain not just for the steering system, but for the entire SRB.
The first 2 minutes of flight is where the IEA is used, from ignition to making sure that it's oriented with the rate gyros in the right direction, to separation of the external tank, and then releasing the parachutes so that we can recover the boosters and reuse them.
Simply put, the IEA cannot fail. If it does, the astronauts' lives are at risk. To make sure it works correctly, the NASA crews will push it to its absolute limit, simulating the G-forces on board the shuttle during its actual trip to space. Astronauts and their equipment will experience up to 3 Gs of force during ascent. It's a bumpy ride. Vibrations of this magnitude can loosen wires, bolts, and crucial connection points. And today, engineers must prove the brains can handle the brawn.
Selecting 17 for vibration test.
3, 2, 1, go.
Proceed.
This machine is applying enormous force to the IEA, nearly double that of an actual launch.
.7 Gs. Everything looks great.
But they're not done yet. The team cranks up the vibration to full strength.
Okay, Janine, full level.
Discovery Houston, go with throttle up.
Selecting the F9 for post-vibe test.
The IEA has survived the test. It can safely be reused on a future space mission. Meanwhile, the rocket motor segments return from Utah by rail. This time, they are filled with their explosive fuel. The quality control team crawls inside each segment to inspect the solidified rocket fuel for any possible damage from the ride. Any cracks could affect the burn, and there are no second chances. When rocket fuel ignites, it can't be turned off. At the point of ignition, a flame shoots down the hollowed-out center of the rocket. The surrounding solid fuel then burns from the inside out to allow for an even blast for the duration of flight. While technically stable, even a small spark can still be dangerous. So technicians take no chances. They walk on static-free mats during inspection.
Everything's looked at least by 2 people, if not 3. All of our processes out here are driven by procedure. We have a procedure for anything you do.
The refueled motor segments have passed inspection. Now, a pair of massive 64-meter bridge cranes lift and rotate the motor pieces. The rocket is starting to come together. The technicians must be very precise when they make these massive sections. If there are any errors at this stage, it could cause a crack, which could cause disaster. The motors are attached. The rocket crews painstakingly examine the outer shell for irregularities and make sure all connection points are properly sealed. The team doubles and triples down on safety measures. Imagine making a mistake or missing a detail at this stage. It happened once. In 1986, the Space Shuttle Challenger was already making history before it left the ground. Krista McAuliffe had been chosen from more than 11,000 applicants to become the first teacher in space. Her trip was supposed to generate more public interest in NASA and help showcase the safety of space travel. But 73 seconds after liftoff, the Challenger disintegrated, killing McAuliffe and 6 of her fellow astronauts. Millions around the world, including thousands of school children, witnessed the tragedy on television. What happened? 6 months later, NASA's official report would state that the problem originated in the solid rocket boosters. What failed was a seal between rocket segments. It's called an O-ring, and when it gave way, pressurized gas leaked out, creating a hole in the solid rocket booster, setting off a chain reaction that caused the entire shuttle to disintegrate. It was the SRB's darkest hour, and it made the phrase solid rocket booster into household words in the US. NASA had to reinvent the entire system before they would allow shuttle flights to continue.
After the Challenger O-ring incident, there were a lot of hardware changes and also a lot of procedural changes, the way things were done.
It should be noted, none of the shuttle disasters were the cause of a single technician or engineer at NASA. They were simply the outcome of small engineering details with enormous consequences. And ironically, each disaster made subsequent shuttles safer. For instance, now 3 O-rings secure each field joint instead of 2 to add another layer of redundancy.
You're on the bottom and you're on the top. Ready?
Beautiful. If it's not enough, the team won't know until liftoff. More than 30 weeks after they were pulled out of the Atlantic Ocean, the refurbished SRBs are about to come together. The final elements are being added. Cables strapped to the external shell, impact insulating foam sprayed over the outer rings. And today, this team will pump high-temperature silicone into joints and holes.
Okay, John, we've reached our viscosity warning. You're ready to start shooting.
This messy job is essential. It will keep the booster's flames from shooting out through key connection points. In total, it will take 35 days to complete these last critical steps. The team is relieved to be done, but each one is nagged by the same thought. Did I miss something?
You follow the procedures, and at the end of the day, things are going to be right. The shortcuts, you cannot afford that. You can't afford the errors. So we've got to do it right. We know that. That's our product.
Next up, the final stage. Stack the segments together and rebuild the boosters. Weeks before the launch, the solid rocket boosters move into NASA's Vehicle Assembly Building. It covers more than 5 city blocks. It's so big, it has its own climate. Employees have seen clouds form inside this structure on humid days. It is here that the solid rocket boosters will be reattached and become one again. The booster segments are stacked to form the familiar shape of a rocket. Over the last several months, they've been subjected to one of the most intensive refurbishments of any single machine you can think of. Now they're ready for the next step, to be reconnected to the towering external fuel tank. And finally, the iconic orbiter, Discovery. The space shuttle is back together. And now, once again, the shuttle will make its slow crawl to the launch pad. It's a rare night launch.
TLC go for orbiter, ATU start. TLC OTC, perform ATU start.
And the shuttle teams are the ones busy now. The crews that have recycled the solid rocket boosters can only wait and worry. As always, liftoff will be the most exciting moment.
I get as big a goosebumps as anybody around. You still get that feeling. And at launch, and you hear the vibration and all of that. It's just like the first one, and it's great.
T-minus 15 seconds. The sound suppression water system has been activated.
And TLC go for main engine start.
We have a go for main engine start. 2, 1. Booster ignition and liftoff of Discovery, celebrating its 25th birthday by racking up science and supplies to the space station.
2 minutes, just long enough to hold your breath.
Roger, roll, Discovery.
The thrust vector control system successfully rolls the shuttle onto its back. One minute in. So far, so good. The SRBs pass the next crucial test and hold together under the G-force of full throttle. Now, as the solid rocket boosters are set to separate, the moment of relief or disaster. And today, the separation is clean and perfect. For the 1,500 people who will again refurbish these SRBs, it's back to work.
We're very proud of our country for having this vehicle, and every time we see one go off and separate, because that's when the first stage is complete, we know that we've done our job, and it's on to the next booster and get it ready.
Very proud of what we do, and every time we see a launch go off and we see those boosters come back and we get the report that we have 2 boosters floating in the ocean, you know, it's real rewarding to do that.
After 30 years, the space shuttle will be replaced by a new launch system called Ares 1. But it will still rely on a solid rocket booster to safely launch it out of the atmosphere. And NASA and its crews will still retrieve it, recreate it, and send it into the heavens again and again.